Okay. How's everybody? All good? Terrible? Why? Why? Okay, that's bad enough. Be careful not to. Yeah, keep the space there. Hey man, how you doing? All good? Okay, so we have a lot of things to cover today, a lot of things to talk about, a lot of different topics, different things. So just a brief overview of what we're going to be doing today. We're going to be starting by talking about value types versus reference types, okay? You have done bonus, hopefully bonus 3. Who had a chance to have a look at bonus 3? Okay? Good, so again, we're going to be starting, our first hour will be about this. Then our second hour, we're going to be working on exercises, okay? Exercises about topics from the previous class. Third hour, we're going to be starting talking about files, how to save text files, how to save data, how to save on text-based files, on JSON files, and I'm not talking about a person called Jason, okay? Then we're going to be doing a little bit of exercise about this, and then at the very last thing that we're going to be doing at 10 o'clock sharp, we're going to be doing our quiz 2. We have 20 minutes. As you get it done, you can just leave, okay? Quiz at the very end, yes. Last 20 minutes. Okay, one quick note that I want to highlight from the start today. That respect. I mentioned about respect in the first class. Why am I mentioning that again? What is that? No. Okay, so here's the thing. From last class, someone sent me an email saying that this person could not concentrate because of side conversations. A lot of side conversations, okay? Now, again, I got a few emails, not only from one person. I got this feeling as well last class. Okay, so again, I'm not gonna name names. You know if you're talking, you know if you're not. So I'm just gonna make it general and say, let's please. No, we have breaks, we have exercise time. Actually, exercise time, it's time to talk. It's time to exchange information, talk, no problem. But when we are trying to convey a message here, and again, we are talking about a topic that is not that easy, at least not for everybody, okay? So, again, if I'm trying to talk and people are talking on top of me, and then I'll keep trying to raise my voice, and again, I'll lose my voice, your colleagues are not able to focus, to pay attention. So again, I'm just asking for a little bit of cooperation, a little bit of respect goes a long way to get our class fully done. Now, if I see that happen, I'll have to name names and I'll have to call you out, okay? So I don't want to do that. So I just want to give a blank statement by saying that, again, colleagues of yours have been, a bit frustrated with that. So any questions about that? Any concerns about that? Okay, awesome. Appreciate it. Okay, so classes and instructs. Okay, so again, this is about bonus 3, classes and instructs, or I can also say value types versus reference types. Anyone has any comments about what you may have seen on the video, or maybe your question that you have posted there? Again, anything comes to mind that you want to, you want to point it out based on the video or based on something else that, about classes, instructs, value types, anything that you got from the video. Okay, so that's fine. I have Padlet open as well, so as we go through this, if you have questions, post them on Padlet, ask me the questions. Class and struct. So again, what we're going to be doing the first hour, we're going to be talking about the difference between classes and structs. They are very similar to each other, very similar, but they are slightly different. And this also comes together with the difference between value types and reference types. Okay? So what we'll be talking about is covered on chapter 9 of the book. Okay? Plenty of links have been posted on Centennial under week 4 about this topic. So again, if you don't have the book, you have plenty of links to go through to reinforce the concepts here. I'm going to start by just saying that value types, when it comes to memory, computer memory, the RAM memory, value types, they are stored in something called the stack. And reference types, they are stored in something called the heap. Okay? So a stack is a very small chunk of memory, of RAM memory, but it's very efficient. The heap is very large, but it's a bit disorganized. Okay? And that's, in a nutshell, that's the difference between value types and reference types. Value types are stored directly in the stack, and reference types are stored in the heap. More complex objects are stored in this large space, which is the heap. Smaller pieces of information like a string, not a string, sorry, a character, an integer, a number, a float, a decimal, a boolean, an enumeration, they are stored in the stack. And I'll be hammering this throughout this first hour via.
Stack and heap is not seen.
They are separated, not physically. Physically, they are in their RAM memory, but logically there is a part of the RAM memory dedicated to stack and a part dedicated to heap. I'll show you some videos, I'll show you some graphics here that hopefully will help to consolidate that and make sense why we are talking about this. What is the relevance to what we're talking about this? Okay? Let's see see what we have here in this video. Okay, so we have an obnoxious guy here, even more obnoxious than me. So, but let's. I think that he has a good message, and if you are able to visualize that way, some people will click with this explanation. Some people may not, but I think it's a good starting point to talk about again about the different types of memories, the stack and the heap. Let's see here if I can get the volume right.
This is the stack. Whenever you have a block of code, everything that happens inside of that block of code is talk about two concepts in memory. Let's start with something called the stack. This is the stack. Whenever you have a block of code, everything that happens inside of that block of code is put on the stack. So let's say I wanted to create an integer I equal to 42. This primitive is put on the bottom of the stack. Let's say I then call into another method, and in that method it wants to deal with something as well. Here's another primitive, the boolean. Now, if we're all in the same block of code, we all share the same stack. If we're calling to a different method, we don't have the same stack. Each method has its own stack, and it's a very efficient way to deal with these primitives. What happens if you want something more complex? For instance, an object, like so. Well, stack isn't really good for objects. They're too big. They're too complex. Stack is designed for dealing with primitives. So then how do I actually deal with an object on a stack? Well, let's say I have object, my object. I can put a pointer on the stack. Technically, that's still a primitive. But I'm going to need to deal with a different type of structure of memory in order to actually use that at all. So That little guy is going to point to this object I'm going to describe right now. Just write object on this card. And think of this little section of memory as being a part of something else. If it were arranged like this, as a stack, it'd be really easy to go through. But unfortunately, you think of the rest of memory that isn't in your local stack as kind of being like this. That's why we call it the heap. In fact, in order to deal with the heap, you have a pointer, and when you set it equal to something, you kind of have to go through here and find a space to allocate it, and then put it there. And yeah, we'll point there, but it's a very slow process. Primitives on the stack are very fast, but these things are much slower. In fact, we have to go through them one bit at a time in order to find anything. So again, this concept of the stack is incredibly fast. When my method is done, I can just take the stack and have a new one. However, the heap works a little different, right? We're talking about garbage collection. Now, what garbage collection does is it has to actually go through the heap and find things that no longer have a reference anymore. And it's the one that decides whether or not that memory can be freed and allocated for something different. So with these two concepts in mind of stack and heap, heap and stack, you can put most of your efficient code locally in a block and use the stack to your advantage. And save the heap for situations where only you need state to stay around. And now you know the difference between stack and heap.
So, I don't know if you heard him mentioning about primitives. Can you give me some examples about primitives? Primitive data types. Integers, characters, booleans, okay? So those primitives, those are the types that are stored in this very efficient part of the memory called the stack, okay? Now, objects, because they are, again, larger, bigger, the data is actually stored in the heap, but we still have a reference about that object in the stack. So the stack, instead of saving in the stack the values of the object, let's say student name, student's date of birth, instead of saving that data there, that complex data is saved in the heap, but a pointer in the stack points to the location in the heap that the data is actually stored, okay? Again, for some of you, this may click right away. You can visualize that. I can visualize that. But I understand that some of you, this is not that easy to visualize. So let's hammer, yes?
So you mean, if we use the, like in the heap, so it's like the memory is the address of that code or the value of it?
In the heap, what we have, in the stack, what we have is the actual value. Let's say if we declare an integer x, and we assign that integer 20. So in the stack, we have a spot there for our new variable, and in that spot, we have the number 20 there. Okay? That's fine, because we have a primitive type being used. However, if we have a more complex type, like an object with a student name, what we have is that we don't have the data in the stack. The data is actually in the heap. In the stack, we just have a reference to that data. We just have the address of that. I'll show it in a different way so we can try to visualize this a little bit better. And with a little bit of code as well. Let's look at this. Now that's where it comes the difference between class and struct. We have struct here. Struct is a value type. Class is a reference type, okay? They are very similar to each other. However, a struct is fully stored in the stack, and a reference type, like a class, is fully stored in the heap. So, again, here is the point that I want really you to understand. If we declare a struct, and again, very simple struct and very simple class, it just has one public field, okay, called age. Here, we are declaring a struct called A, and we are allocating memory to it. And then we are saying a second one here and we are saying that B is equals to A, okay? Now we make a change to A. We say A.age equals to 10. When we try to print this out, the age in A will be different from the age in B. Because when we did this, we created a copy at this point in time of whatever information was inside A, we copied it to B. Copy. So it's a copy. Okay? So that's how value type behaves. If you have X and Y being integers, and you make a change, you say X equals to 10, and you say Y equals to X, the value gets copied over. If later on you change one or the other, they won't affect each other. So value types, if later in the code you make changes to one or the other, they don't affect each other, because what happens when we assign, we create a copy. Okay, it's a copy of the information. Okay, now as opposed to when we're dealing with reference types, look, it's doing pretty much the same thing. We are declaring a class A, we are creating, allocating memory, then we are saying declare B, but B is equals to A. Now look at this. If we say that age of A is equals to 10, B age becomes 10 as well. Because when we do this, guess what? We are not creating a copy. We are just making A and B that are both in the stack pointing to the same address in the heap. So they are not actually two different things. They are two pointers pointing to the same location. Yes?
So you said that the struct values, right, they're saving stored in the heap. What about
In the stack.
in the stack?
Yeah, so this is saved in the stack and this is saved in the heap.
One more time? This is in the stack?
This is stack and this is heap.
Okay.
Okay? Again,
Like if you assign the number to A after writing B is equals to A, either way it's gonna 10 is going
to be in both. But just think about this. It's not really true. What happens is that A in the stack, it has address. I'm going to just throw an address number here. Address 2000. When you say B equals to A, what happens is that the address number 2000 gets copied into B.
B is becoming A.
So actually, it's not so much that it's becoming. Just visualize this, in the next slide will help you with that. We have A, which has the address 2000. We assign to B. B becomes 2000 as well. So both of them are pointing to this location in memory, which has the address 2000. That address, there, the data is there. So it's not that we are making change to two of them. Actually, they are the same. They are two different references to the same object. Yes, 1 second.
If we were to change B, then would that also, because it's changing the
Yes.
address, would also affect it?
It would.
Okay.
Yes.
So basically we have in the first, like, yeah.
Struct?
In the struct, we have like, we are assigning two values, so we have two addresses.
Yes.
And we're allocated two different like addresses where we're gonna put our variable value.
Yep.
And on the other side, we are making just one address and allocate all the changes there.
That's a good way to put it. Yeah.
But like, I don't
1 sec.
I don't want to drive on this, but
Okay.
what if you had put value type B equals new value type?
Sorry, say it again.
What if you had put value type B equals new value type?
Equals new.
And then do A equals B.
Okay, so if you put it new here,
Value type, yeah, new value type, and then we do A equals B.
so here's what will happen. Let's visualize this. So you're talking about this case here or that over there? No, this case here, if you just assign, if you allocate new memory, and if you assign to each, like later you do this, later, then you're going to create a copy. In any case, you're going to create a copy. Either way, either with new value or no new value, you're going to be creating a copy. In this case here. In that case, even if you say new new ref type equals to B, even though then later on you assign B equals to A, then you're going to create a reference, okay? When you do this new reference type, actually you go to the heap and you allocate memory for that object to be stored there in the future. If you do that with B as well, so we have two memory locations there allocated. But then if you assign one to the other, the address of B now becomes the same address of A. So it's like that second spot that was reserved will be getting rid of eventually, and A and B are pointing to the same initial location. You had a question? Yep.
So we don't need to use the constructor for B here, like B new value type.
Well, here's the thing. To be able to use the structs, we need to allocate memory for that. So if you don't say new,
I say for B, we use...
For B, no, for B, because we are assigning, we don't need to call a new value types, okay?
But if we do, there is a new heap for the B,
Yep.
then we say A equal to B.
Yeah, so the values will be copied.
That's the same question I kind of asked pretty much. And they said no.
So,
Yeah. That's the same.
No, okay, so no to which question? Again,
The
that,
question that I asked, because it's asking pretty much the same question, because when I say value type equals to new value type,
yeah,
your values have A, so you receive the same new value type, so actually you're repeating the same thing.
So, but the result is different. Now
So it's actually the same. It's gonna,
now if you get to assign or not,
if you assign a B, then we say A equal to B.
A equals to B. Okay, let's step back. So we are declaring and initializing A. You're saying that we're doing the same thing with B,
Exactly.
like new value type. Okay, so when you say new one, new A, new B, you have two memory locations here reserved. If eventually you say B equals to A, what you are doing is you are copying the values from A and setting to B. They are not pointing to the same location. You're creating a copy of the values over. So regardless, my point, and I don't know if this is your point, is that regardless if you use new value type or not for B, it will do the same thing eventually if you assign one to the other. Yep.
So if you write value type B is equals to new value type, for example.
Yep.
And then you write B is equals to A. Whatever on B, it's going to be copied to A, right?
B equals to A, whatever is on A
On A
goes to B. Yes.
And still it's going to be stored on A as well.
Yes. So they remain each other. It's a copy. They can be changed independent from each other. Okay?
so this,
Okay, let me do one thing. Let me move forward to the next slide, because next slide will help a little bit on that. And I'll come back so we can have a look at this thing there. Okay. This is hot off the press. I just put this slide together today. I said, I need to try to explain this a little bit better. So let's see if it works. Okay, so here we have a value type, a struct, and we have a reference type, a class. Okay? So before assigning B equals to A, this is what we see. We declare A in the stack. Again, A is a struct. Okay, so it's on the stack. And age is 10. And then we have B declared. And initially there, we have, if we were saying B a new value type, we would have a new spot here. And if we don't say age, what is the value? It's an integer, so it becomes 0 by default. Okay? So we have two spots here. And then, at the same time, we do something similar to A, but now we have a class. A is as a class. Now, here's the thing. On the stack, we don't have the age 10 right here. On the stack, what we have is address number 5,000.
Oh, it goes to the heap because we created an object?
Yes, yes. Here we have address 5,000, and then the actual data will be stored in the heap in a slot called, I'm going to say called 5,000 with the address 5,000. And on that slot, we have object.age equals to 10. So the data is in the heap here. So this is before we assign A to B. Okay, this is how it looks like. Then we do the assignment.
But value doesn't go to heap. Just references go to heap.
The value,
Value, the A equals to 10, doesn't go to heap.
it does, no, it doesn't. No, in the value type, when you're talking about value, nothing goes on here in the heap. Nothing. Nothing goes on there.
So they don't have the address like the,
They have the addresses here. It's right here. But it's directly in the stack.
okay.
It's direct, the slots that they have here is the actual value. You have a question?
No.
Okay, so then we do the assignment. When we do the assignment, value type B equals to A, what happens is that for a struct, age is 10 for A, that's the original value, and now the age of B becomes 10 as well. But again, they are different memory locations. However, when you look at the class, which is a reference type, when we do the assignments, well actually, yeah, that's right. Ref type B equals to A, the address of B becomes 5,000 as well. So both A and B are pointing to the same box in the memory. Same location in memory. Same location in the heap memory. And that's why we don't have really two objects. We have two references to the same object here.
But that's different from the previous slide.
Is it?
Did you say B is equals to 10 now? In the struct.
B is equals to 10.
In the struct.
The age. What is that?
Value type B is still 0 in the struct in this case. But then in your case it's 10. You gave
But
the
this
value
one is value
type.
that
Yeah.
That's because initially the value of
The outputs.
A dot age is 0.
No, it gets a copy, right? Of
Yeah,
A.
and then the-
Actually, that's a good point. That's a good point. Yeah,
B is supposed to be 10.
that's fine. So here, so the assignment, yeah, you're right. When we do the assignments, why did I say that? There must be a reason. Oh, yeah, because then it becomes afterwards. Okay, I get it. No, you're right. This should be, adjusted here. So after the assignments, because A was not assigned yet. Yeah, this needs to be, okay. This needs to have happened as well. Yeah, I did it slightly different. You're right. Here, after the assignments.
Maybe we just copy and paste it visual so we can check them.
No. It's just that I think that I bypassed a step here. It's set to 10. Yeah, so my example is slightly different from that example. You're right. I need to adjust it a little bit. But that's what happened when. So again, I tried to put this today, and this really, I didn't look at that. I need to reformulate this. But here's the point that I'm trying to make, which now it becomes a little bit more complicated because the assignment here.
Because you didn't assign it for 0 for this example.
So we did the assignment, value type. Yeah. So the only different thing here is that this second one, as you said, it should still be 0. That's it. Okay. The second one should still be 0. If after we do the assignments. Yeah, I will update that. There's still something there that needs to be adjusted here. But,
I think the video that you told to watch for the bonus
yep,
explains it very well.
I will play that. I think that I have it here to be played, so I'll play that in a second. Yep, person.
Saying for the first one, struct, if B equals A, B is still 0. Is that what you're saying?
Sorry, when you do what?
The struct.
Yep,
A is 10.
yep,
So A is 10, yes?
yep.
Okay, now you're saying B equals A, yes?
Yeah, so that's what I need to adjust here.
Okay.
I'm just trying to think here how I adjust that. Because I want this to comply with this code here.
Okay, so you see the second, I remember in the video, so if you want to change A, it would also change B, or it wouldn't have changed B. That's what you wanted, you were saying in the struct. If you want to change A afterwards, B wouldn't change, right? So for the struct, let's say A is 10, B is equals A.
Let's do one thing. Let's forget about this graphic, because I need to adjust this graphic a little bit better. So, no. It's just that what happens here is that we have it in slightly different order. Here, I'm assuming that the initial state, age is 10. And here, the initial state of age is 0, it's not 10. So again, I'm bypassing one step here. So, to be honest, let's just focus on the codes. Let's bypass I'll play the video, but I'll adjust the graphic to make it have more sense. But ask your question now again. What was your question? The point is this. In the structs, when we assign, we create a copy of the values. In a class, when we assign, we refer to the same objects. So, the same location. So if we change one, we change the other one. In the struct, if you change one, you don't change the other one. That's really the main point that I want you to
Depends on when you change it, right? If you change it before you actually assign it, you
before.
go back and you change it. So let's say you say A is 10, A is equals 10, and then you say B equals A, and then you do A, you change A, yes, okay, you want to change. But if you go back and where you say
Back where?
10, back before when you assign B, and it would be the
Oh, before here, before this.
then it would.
Yeah, because they were not assigned. Yeah, so again, if you do it right here or right here,
But afterwards it wouldn't change.
correct. Okay, let's have a look here. For the ones that did not run through the bonus, I think this is the
We've learned how
video.
to create our
You said it
own
right, you said it
classes
right.
in C#.
Just,
We come to an important point in the course where we need to learn different
Yeah, I need to work on that
value
one.
types and reference types. C# has two main types. There's value types and there's reference types. Value types are all of the primitive types that we've learned about so far. Things like integers and longs and shorts and decimals and chars and booleans and so on. And there's also a thing called struct, which we haven't covered yet, but we will cover later on in the course. Anyway, those are the value types. Reference types are classes, arrays, and a couple of things called delegates and interfaces, which again, we haven't yet covered, but we will cover later. So why is there this difference and what's so important? The main difference between value types and reference types is how they are handled in memory. And the best way to learn this is to see an example. So we'll compare the value types with the reference types. Now, for a value type, let's take a really simple example. Let's suppose I have a variable I, and I declare it as an integer, and I set its value to 5. Now, when I do that, the C# compiler goes out in memory and makes a little box called I, and it puts the value of 5 in. If I declare another variable called J, and I set it equal to I, then the compiler sets aside another little box. This little box is called J, and it also gets the same value as I, which is 5. Now, the important thing to remember here is that J is a copy of the value that's stored in I right now. So if I go back and change the value of I to 3, the value of I gets changed, but the value of J does not get changed because these are different memory locations. Now let's compare that with how reference types work. So suppose I made a class called point, and inside my point class I had two integer member variables, x and y, which represent the coordinates of the point. To create a new point, I would declare a point class variable named p1, and I would use the new operator to create a new instance of the point object. Then I could do something, now since these are public member variables, I could say p1.x and p1.y are equal to 10. Let's watch what happens in memory. Well, in memory, that little location called p1 for the variable gets created. But what also gets created is a set of bytes somewhere else in memory that actually hold the member variables. And p1 is not actually containing that data, it contains a reference to that data. There's this little reference that goes out into memory and knows where x and y are stored. So let's suppose I made another variable called point p2. And rather than doing new point, I say point p2 is equal to p1. Well, that creates a little local variable there called p2. But watch what happens. The reference gets set to the same reference as p1. They're sharing the same reference to the same location in memory because I didn't make a new instance of the point. I simply set p2 to be equal to p1. And when you do that with a reference type, you're sharing the same reference. What does that mean? Well, if I then do something like this, where I set p1.x is equal to 20, it changes for the both of them. So even though I didn't do anything to mess with p2, p2.x is now having the value of 20 the same way that p1.x is. This is an interesting side effect of how reference types works, and you need to watch out for it in the code. Let's go over to the...
Okay, so I guess the points that the guy makes here is very clear and less confusing than the way that I was trying to make my point across, okay? So I'm just gonna go here and just do a quick quiz so we can, actually before we go there, just want to reiterate that value types, we have a bunch there, integer, floats, decimal, double, longs, boolean characters, enums, structs, which we have seen right now. In reference types, we have quite a few strings. Strings is a tricky one, okay? We tend to think that strings is a primitive, but actually string, if you think about that, is an array of what? Of characters, okay? Okay, so again, it's a reference type. Classes, arrays, lists, okay? Let's have a quick look at this one here. Okay, can you open Nearpod? We have a quick quiz to have a look there. The first one is very simple, it's just a concept. The second, once you are done with the first one, keep the browser open because I'm gonna move to 3 questions and you can just stay in the same page. Okay, so let's just have a quick look. The first one, very simple, again, just to reinforce what we are talking about. Difference between a value type and a reference type. A value type holds the data within its own memory allocation. And a reference type contains a pointer to another memory location that actually holds the data.
So for reference type, we have a same memory location that contain A and B at the same time with same value.
Yeah, we have a reference that to a memory address that contains the entire object there, yes.
A, B, C, whatever, but for all of them, same location.
Well, what do you mean by ABC? The objects? Only if they are, if they have been assigned to each other. If you just said new A, new B, new C, then they have 3 different locations. Only when they are assigned to each other. When you say A equals to B, B equals to C.
What was the question that here is a pointer to the another memory location that holds the real data?
So you're talking about the reference type. Okay, so in the reference type, let me just use my own graphic here So what was your question? This is the scenario here.
I mean that in the quiz, naturally,
Yep.
they point to the different.
Yeah, this is the point. You see, 5,000? This is what it's called a pointer, because it's an address. The value 5,000 is not a value that I want to use. It's just an address to where I want to go to get the data that I want. So it's just saying, the data is not here. This is the address where the data is. The data is here. Okay? Okay, I'm going to move forward, and we have 3 more questions there. And again, if you kept open, you're going to see it moving forward as well. Otherwise, you have the code there again. I'll give you 2 minutes, 3 minutes to get that done. Yep.
You mean like you have A equals 10 and then you have like B, C, T equals A. Is that what you mean?
If you keep assigning one to the other one, if you say A equals to B, B equals to C, only if you assign them, they share the same location. If you create a new object for each one, they'll have their own place. They have their own memory there. I'll flip it over here. See, the reason that they are pointing to the same one is because you assigned it B equals to A. That's why they share the same location. However, if you say A equals to new ref type, B equals to new ref type, C equals to new ref type, each are gonna have their own square here, independent from each other. They're gonna point to their own square.
Well, your question is asking if we can do, I mean, it's asking a value, not a reference.
Which question?
Is it possible to have multiple pointers with the same value type?
Yeah, so whenever we mix, value type, we don't have.
You're saying that, so A equals 10, and you're saying that B equals A, and then C equals B, and then D equals C.
Okay.
This is possible?
It's just asking if you can have multiple values pointing to the same value address. Actually, if you think about that for a second, the values that are in the stack, they don't have an address. The actual variable is the address. So that, we're gonna get to that one, but that is not possible, actually. Let's have a look, and then we comment there. Okay, so first one here. This can go away. Mark the ones that are examples of reference types. A string. Is it a reference or a value?
That's reference.
A reference, okay? So again, it's a very tricky one that can be very confusing. We tend to think that it's a primitive, but strings are not primitives. Think of strings as an array of characters, okay?
Sir, can you say something about how we decide which one is valid and which one is
How to decide?
how we just divide? Yeah.
Well, I think that the basic types, like the primitive types like integers, the numeric ones, they are all primitives, so they are all value types, okay? Then we get to booleans, we get to enumerations, which, to be quite honest, then you have to kind of remember that. But you have to think, enumerations, what are they? They are numbers. Characters, it's one single character, it's very basic, so most likely it's a primitive. String is a set of characters, so it's a little bit more complex, so it's a reference type.
What about array of strings?
Arrays are always reference types.
Even if it's okay.
If you put the word array, it's a reference type, okay? So reference type, integers, reference type, value. Value, arrays, reference types, objects of classes, reference types, okay? By the way, how we have done here. Okay, not that bad. The tricky thing with those is that, and it will give like a wrong answer if you don't check all of them. Okay, mark the ones that are examples of value types. Doubles. Yep. Floats. Yep. Structs. We just went through yes, and enumerations. Enums. They are as well. Enumerations, remember that behind the scenes it's really just a number that is being stored, okay? All of them. Now this one here. Is it possible to have multiple pointers to the same value type address? Value type addresses, they have a memory placed there, but we don't have multiple pointers to them. We just have one variable to them. Let's say we declare x as an integer, y as an integer. We cannot have both of them point to the same memory location. They each have their own memory location. That was what the question was talking about, okay?
So let's say I've already declared a variable
A.
And B is pointing to A. So
A is okay, what type of variable is that one? Is that a reference type?
Yeah, value type integer.
Okay.
So B is pointing to A. So doesn't that mean...
It's not, so it does, there's no such a thing as B points to A. You can say B equals to A. Then whatever value is in A gets copied over to B. But what is that?
Pointers for storing the...
Not if they are integers. If they are integers, they each have their own memory location.
No, they do have their own memory location.
Yep.
It can have the copied address of A, right?
How would you do that?
With the help of pointers.
Oh, okay. So again, if we are looking for lower, I would say, I mean, you can get to assembly very quickly, and you can do whatever you want with assembly. I'm talking about using data types. We're talking about data types here. So again, if we have simple data types, we are not having pointers here, okay? So again, if you go down to, okay, I want to bypass data types and work one level deeper than what data types are given to me, you can always find a way to go deeper and work around things. But out of the box, this is what the data types are bringing to us. Okay? Yep.
In value types, what if we set up like for example, we set up a C, like A equals to C and C equals to B.
Are we talking about reference types or value types? A reference type. Okay, so if you say A equals to B and B equals to C?
No, A equals to C and C equals to B.
A equals to B. Okay, let me visualize this. A equals to B and B equals to...
A equals to C.
A equals to C.
And C equals to B.
Okay. I have to write this. A equals to C and
C equals to B.
C equals to B.
So what I do is I set up like the...
Guys, okay, can you please focus a little bit here? Come on.
I just set up a medium, like, what do we say, like medium location. Like two of them both point to the...
Okay, so are we talking about, again, this is reference type that you're talking about, isn't it? Is a class?
Yes.
Okay, so ref, okay? So again, what's the question?
So if, like, I'm wondering if I just set up like C for like, is it meaning like for both of them pointing to the same location?
Right now, all three of them are pointing to the same location.
All three of them.
All three of them. Sorry, not really. Not really, because I don't know, I mean, right now, so A,
Whatever is on B, it's going to C and
okay, so C, so A is pointing to C now, and then, so, okay, okay, let me see here. Okay, so, yeah, but here's the thing, B, we don't know what is being done with B there.
But B was assigned to C, which was assigned to A already.
Yeah, but B may have its own value there, may have its own memory location. No, it's a reference type. This is a reference.
Right? Within the value type, wouldn't be pointing to the same.
Okay, are we talking about reference type or value type? So you're changing the question.
Reference type that we're talking about.
Okay, so B there, we don't know what is happening with B. I know that now I know that C now is pointing to B.
Yeah.
See, you have to imagine this, you have three slots there. Let's say A, B, and C. What you're doing in the first line is that you're making A the same as C. Okay, in the second line, now you have B, that whatever is on B becomes the value on C. Whatever was on A is still on A there. A was not touched anymore. It's not, we're not doing a little train here. I mean, it's not one is hooked up to the next one and it's hooked up to the next one.
so this doesn't work.
No, it's not about does it work. I mean, does it work for what? What do we want to do? I mean, do we want to connect all three of them?
What if in value type?
No, okay, so again, articulate your question. What's your question with that?
Like, is it like so B is like now that B is different with A. That's
Yeah.
my question.
B is different than, yes, it is.
Because they are not just not like the last example, like A equals to B. Like in this condition is become different. Like,
Yeah, because B, we don't know what's going on with B right there.
Yeah.
I mean, B was a different place there.
That's what I'm wondering.
Yep.
Yes.
Anyway, let's have a quick break, 5 minutes, and we come back. Yes. Yes, I will. I'll be there. 1 second. I'll just drop by there. What's up?
Now, I assert a string A equal to something.
Yep.
B is equal to A.
Okay. Okay.
Now I change the A. Both of them are reference. Now the value of B must be changed.
Okay, so let's see here. So A equals to
Something.
A, yep, equals to B, and B
Equal to
equals to A.
Now I change the A.
Yep.
Now the value of the B change or not?
Okay, so let's see here. String B. So, assuming that, again, A and B are strings and they are reference types, they should, and they are not.
Not. Now
Now,
the B, A
okay,
and B are different.
so maybe there's something a little bit different about strings that's,
I have
okay.
one idea by myself. I've understood.
Go ahead. No, I think that my thinking is that there might be something a little bit different with strings, but go ahead. What's your theory?
A has a different memory location.
Yep.
B has a different memory location. Now I say, okay, B equal to A.
Yeah.
That one is my base reference. but I didn't change the B, I changed the A.
So if you change B, change, let's say, put something on B. So B, yeah. Yeah, and then let's see how things run there. Just try to run it. Yeah, so I think that string might be off from this description here, but I'm sure about that if you make it a class. Try to make it a class. Instead of just a simple class like the one that we did with
Make an objective for the class and
yes, and then assign to a second object. I'm sure that this will work. Now, again, string, I don't know, maybe there's something a little bit odd about strings that, even though it's a reference type, but it does work like that. I'll have a look. It's a good point. But if we are dealing with objects, they will present this behavior. Yeah,
tried that
but
one too.
it works.
but for the string,
String.
only, reference doesn't work.
I'll look at that. It's a good point. It's a good point. I would be expecting that it will behave like a class, like an object, but it doesn't. I'll have a look at that. There must be an explanation for that. I'll bring that. Okay.
Totally. What's the purpose that a string is reference?
It's not really a purpose. It's really, it's by definition, by design. Again, there's no particular purpose. It's just that it's a more complex structure. It's about the complexity. So again, characters is a value type. When you put them together in a string, you are making that becomes a more complex structure, and then considered as a reference type. But again, let me look at this part here. Yeah, sure.
These two have two different memory location.
Yeah, that's. Oh, you know what? Try one thing here. Try one thing. Can you put capital S?
Capital S.
Capital S, string with capital S,
Okay.
both of them. Can you just put the S as capital?
Oh.
Just the S, capital. The other one as well. Can you run this? Can you move it over a little bit here? Okay, so yeah, I'll have a look because it can be uppercase or lowercase, and one is they behave slightly different. I'll have a look at that. It's a good point. I'll clarify that. Okay? Yeah. What's up?
So like I got this, in this the value of b would be 0, right?
Yep.
But like,
Now, forget about the graphic here because I need to adjust the graphic. The graphic is slightly
what
off.
I understood by this
Yep.
was like you are creating an object, like A is new.
Not an
value
object,
type.
a struct.
Yeah,
Yep.
Structure. Yeah. Then you are assigning the value type B to A.
Yep.
After the assignment, you are giving the value A10.
Yes.
That's why the B is 0. Like initially, you have, if you have assigned this thing before this step, then B would be happening.
Yes, but again, they are independent memory locations. If you change one, the other one will not change.
yeah.
Even after this.
Yeah, that's what I understand. But in case of reference, it's different, right?
Yes.
Because
When
they
you
are
assign-
assigned to the same memory location.
Yes, because of this line. Because of this line here. Okay?
Okay. Thank you, sir.
Okay, awesome. Any have a question?
String is a reference data type, right?
What is that?
String is a reference data type.
String, yeah.
Yeah. So why this works?
Yeah, so actually we were discussing about that over there. I will figure it out. I'll check it.
Is a data type.
Yes.
Not a string, not a reference. It's value data type, right?
Yes, value, yes.
Then why this gives no error as new keyword is used to initialize?
Well, I mean, integers, I've never seen integer being used like that.
But it works.
It works?
Yeah.
Again,
I just tried it, and this is my bonus 3, which I have.
that's okay. That's okay. So leave your bonus there.
Find the
Let's
same
sort it out.
thing in my bonus, that's why.
That's fine. I'll have a look, okay? Okay. So
Yeah.
But it's already
Okay, so here's the thing. A few questions came up, which we have seen a slightly different behavior with strings. Strings not really following a lot of this definition here. I'm gonna have a look and I'll bring the answer back. Now, I would like to do this. Can you please open your eCentennial under Contents? Let's go to week 4. And under week 4, let's have a look at this exercise, Programming Exercises 03, version 2. So, what I would like you to do is to practice this exercise here. Again, this exercise is about UML, it's about overloading, it's about constructors. This is the type of thing that you're going to be doing, not only for assignments, but also for your tests, okay? So, let's practice this a little bit with what we have seen so far in terms of UML, in terms of constructors, in terms of overloading. There's a step-by-step that I put together. You just go one by one, create your project, define your class, create the constructors, implement each constructor here based on the UML diagram, and then just go down, implementing item by item from this list. As usual, I'll be walking around, I'll be giving you a hand if you need, but again, use this time well, even enumerations as well. You're going to be declaring an enum and using that. Use this time to practice what you have seen so far, and again, count with me to give you a hand in case you get stuck, okay? Any questions? Again, it should be straightforward to understand. If you get, stuck on any technicalities there, I'm here to give you a push, okay? Again, this is Programming Exercises 03, version 2. And as usual, I'll be providing the solution for this exercise by the end of the week, together with a video explaining step by step on how to put this together, okay? But again, in the meantime, let's do it here, and I'm here to assist. Yep.
Have you uploaded the solutions for last exercises?
For the ones that I provided, this one here. For this one, under week 2, let's see.
Week 3?
Week 3, I didn't go through those exercises formally, so because I need to cherry pick the ones that, because some of the ones here, we have not seen the entire content, so I decided to skip that one for now. But again, let's focus on, for the other, on the week 2. Yeah, see, solutions here. Okay,
Thank you.
no problem. Whoops. Okay, I'm going to take a quick attendance here. Achille. Amira Salam. Andri. Yep. Ashdeep. Basil. Christy. Daniel. Diogo. Dirk. Ederson. Edgar. Farzan. Gopika. Gukrat. Harmandeep. Hoi Fong. James. KU. Lincoln. Mamadou. Malmin. Matthew. Maziar. Michael Dean. Nabil. Parwinder. Prabhaldeep. Premchand. Yep. Samvel. Yep. Sian. Sinap. Yep. Talin. Wei Hao. If I did not call your name, let me know. Pramandeep, okay. Prabhaldeep, correct? Last name? Harmandeep, correct? Okay. What's up?
Could do the quiz early today, so we can. I was hoping I could maybe get don't feel well.
Okay.
Is that possible? Just today, make a.
I just have to find the right spot there. Okay, let me give it a try.
If it's not, don't worry.
No, let me give it a try. Okay.
If it's okay. If it's not, then.
Okay.
I don't know yet. What's going
8 o'clock. It opens for you, and then you have 20 minutes. But just for you.
Okay.
So everybody go regular, but again, keep it to yourself. keep this to yourself.
This by default. Okay, I see. Make a reference to that.
This would be whatever value assigned to some I was absent last week, so
Okay.
I'm not sure what does it mean is set here and there's a value here.
Okay.
So this is property, right?
Okay. Yeah.
Right
So you should capitalize N, because in the
Capitalize N?
yeah. So capitalize N. Keep. Well, I get it. You are using underscore to
Yeah, yeah.
signify
Yeah.
private, correct?
Yeah.
Yeah, you can use that. That's fine. That's okay.
So
So no, actually capital here, but keep what you're doing there.
Okay.
So what don't you know is that the value mean. What was your question again?
like I'm not sure what I'm doing here, like set on the value.
Okay, so you better. I can briefly explain to you, but we have an entire class to cover that. So you better. So you know that we record the videos. Yeah. So you should if you miss the class, you should check the video. Okay. But I can tell you. So. Get returns the value of this private here, and sets. So when we say object.name equals to, let's say John. So John gets stored in this name underscore name, and when we say object.name, let's say to print out or to get the value, this other one, the set. Sorry, I said the opposite. When you assign the value, set runs. Value is John, and John gets stored in the private field. When we want to read the information from name, the get returns the value that is stored in the name. So one is used for storing the value, the other one is used for retrieving the value. And you do that for each property. For each one of them, you do it the same idea. Okay? Any question?
No, I didn't figure it out actually. So over here it asks for commission rate to become read only.
Yeah.
Yeah, over here. So read.
So commission rate is read only here, but it sends here, isn't it? Is that your question of how it will get there?
Okay, that's over here. Yeah. So how do I set a value if it's a read only?
Because then you bypass the property, go straight to the private field. You can go straight to the private field.
Of course.
You can
So
bypass
instead of going to
the property.
Okay, so I'm not doing
you go
capital,
straight.
I'm doing
Yes.
small letter. Okay.
But doing the small letter, there's a caveat that you need to use
Okay. To
something.
bypass it. Okay.
Okay?
Thank you.
No problem.
I have a question.
What's up?
It's not about that.
It's okay.
I copied this part of the link
Okay?
and I want to search in the Google.
Yeah, but if you type in there, it will run the link, isn't it? I mean, hit the
Yeah.
enter. So you can type in, you can try to type there inside the
thing
search.
is, it should do something, but it's opening something.
The site again.
No,
Can you paste, open the text editor? Like a notepad or something like that.
do I have? Oh,
Yep. Can you paste there?
it's okay.
But the beginning, but HTTPS column. We're missing the column after S, the 2 dots there. 2 dots, I mean the column. This, yeah. So copy that, see if it goes straight, like that.
Now it doesn't work.
Strange.
I
don't know, I mean, the...
problem with my email. Is this gonna work? Oh,
It's
yeah.
going.
Oh, it's working. Like, I reinstalled the Windows. After installing the before the installing, every time I type Gmail or other mail,
Yep.
it was sending me to my high school website.
Really?
Yeah.
Try to go incognito. Go here. See if you can go incognito there. New incognito. So paste it there. Give it a try. Did you, to log in that site, did you use any Microsoft credential, anything like that?
Nothing, it's just open source.
Okay, go back there. Go back there.
When you search in Google, it should bring it. It's this one.
Okay, so.
Is this? No.
Because, so here's the thing. Maybe the site, just the root of the site, needs authorization to be given access, and maybe it's using. Have you tried outside of here if it does the same thing?
No, this first.
I think that root that you're putting there, it requires access to be able to access it, and it uses Microsoft. So your Microsoft credentials, it's trying to say, hey, you need to log in.
To eSend,
Not to send it to somewhere that can validate you as you have an account.
So if I log into eSend, it will open?
I don't think so. It's just trying to send you somewhere to validate yourself. Most like that site use Microsoft behind the scenes. So because of that, it's trying to say, hey, you better enter your credentials here, because I don't know who you are. And it's redirecting to the site because you have access Microsoft stuff from the Centennial's platform. No? I think so. What is that?
Trying to validate?
It's trying to validate. I think it's trying to validate you. Yeah.
Oh, but that's weird.
Yeah. Did you get it? Did you get it to work? Is it 2 minutes? Okay. 8 minutes? Yeah. It's a clock.
I have to use this for the contractor.
Well, so here's the thing. You have to use this if you are using the private properties, and you are, so that's fine. However, for instance, for name, for sales amount, you could have used the property as well. So if you have assigned it to the capital name, capital N name, you would need this.
But there's no difference between these two.
There is a little bit of difference, because if you go straight to the private field, you are bypassing the property. So you are working around the property.
Okay, but the references changed now.
That changed. I mean, in our simple example, it doesn't matter because we are not doing anything special in the get and sets. But what I want you to keep in mind is that when you say lowercase name, like this, you are going straight to the private fields, bypassing the property. If your property was doing something smart there, anything interesting, you would be bypassing that. You can because you are working inside the class. Yeah. But again, outside world will not be able to do that. That's fine. But for the commission rate, you have to do this because commission rate is read-only. So you could not set commission rate capital C.
Yeah.
For that one, you're right. Because you cannot set to the property. Yeah, but for the other ones, you could go through the property. Okay?
So, but now when I use this, now all of these public properties also have a value.
Yes.
Because they have a set that gets value from that private one.
Yeah.
Got it.
Okay?
Thank you, Professor.
No problem.
What's the difference between this string and this string?
One behaves slightly different, but to be quite honest, I don't recall. How about we try to find out?
Okay.
How would you find that on Google?
I will just write it. What's the difference between?
So let's have a look.
Okay.
Okay, so let's see. There you have. It's just an alias, so it seems to be the same thing.
But it is still unsolved. My first.
What is that?
Doubt. My first doubt.
Good.
That it's a class. Then also works. I showed you.
Mm-hmm. Give it a try to see if it works. Yeah, you can research. You can, yeah. Anyone needs help here? Anybody?
Not right now.
That's not right now. Good. Okay. All good. Good. Yep.
Here it is read only, right?
Yep.
So I cannot like distinguish like why can't we make all this all by this dot by using this.
Okay. Well.
This read only means this. Or?
No, read only means that there's no set in the. See, show me the commission rate property here on your codes. Where is the commission rate? No, commission rate. This is the private field. What is the public property of commission rates? Okay, commission rate. So you get rid of sets. So because it's read only, it only has a get.
So it only receives the value.
It only provides the value. The way it's gonna store the value, I'll leave it up to you to come up with a solution for that. How are you gonna set the value of, well, and again, rethink about your names here, okay? Because they should match, see, commission rate lowercase, this should be commission rate uppercase C. I take points if you do like this. I mean, you're not using the right case, okay? Again, you should practice this because otherwise you're gonna get some points deducted there. Go ahead. What's up? Yep.
I'm done with the constructors.
It's fine.
And get as it is done.
Got it.
What do I do next?
What's it that the exercise asks you to do?
So it says with this we'll implement the following three constructors.
Okay, so you did. So scroll down.
And
Scroll down. No,
okay,
in the yeah.
The constructor set the value.
Just keep scrolling down.
Okay.
So it's all done.
Yeah.
5, 6 is all done.
No, I'm doing it. So it's like calculating this, right?
Yeah. So you just go point by point. Okay. Again, commission rate lowercase c, that's fine, but here should be commission rate uppercase C. Keep the same name. Again, you are practicing this. If you're going to go to the test and do this, I'm going to ask, why are you calling this? Okay, make sure that's consistent. What's up?
The object.
Be there in a second.
The object
Yep.
name should be the same as method names.
You should keep this. Yeah, name. Yep, correct. So you should say sales amount, commission rate. I get it, but what if I want to keep name there? What do you have to do? You have to, yes. So use that. I'm trying to see if you can
Another problem. What's the
move the mouse over. Okay, see, this is a constructor. Constructor doesn't have a type, a return type.
private?
You see the void here? It does not have a return type. It has no, it's a constructor. Constructor doesn't have a return type, even if it's void.
Do we need an actual number for like actual value for the like first Like,
I'll be there in a second.
because the first question they have like they have to they ask the question asks like, do you have like actual value for the 3 fields?
Yeah.
Do I have to set up a real number for that, or is okay, or I can just
Or what?
or like I can just set up a variable.
Okay, but you can put in a variable. You can put in a variable. That's fine.
Okay, so my question is.
Yeah, go ahead.
So for this first one, I don't know if this is correct first.
Okay.
The way I
Okay.
put it in.
Yep.
So now the
Sounds
first one,
fine.
is this correct here? Because
Yep.
this is only a read only.
Mm-hmm.
So now you say commission would be your sales amount times this commission rate.
Correct.
Because we have to set a value to this one, right?
Mm-hmm.
So for us to set the value to this, we have to set it in the main, right?
Yeah, when you are creating the object, you're gonna use the constructor that will ask for. Yeah, so that's how you're doing there. Show me again there.
So here, because
Commission
here,
rate.
commission rate.
Okay, so but make sure that this commission rate ends up here as well. You are not assigning commission rate to this commission rate. You are not assigning yet. You are using it, yes, but you are not assigning the commission rate to the commission rate.
Because I thought it's only a get, because if I do, for example, here, commission rate, sorry, equals commission rate, I get an error because
I get
it's only a
it.
read only.
So how do you fix that?
This? No.
You're gonna use this, but it's not
Because I
only
did that
it's not
first.
only that. There's something else beyond this. This keyword. Yes, you're gonna use this, but again, the point is this is read only. Then how are you gonna store the value?
So you need to put set.
Nope. Don't do that, because then it's no longer read only. So
Because it's a private here.
that's okay to be private. So you're not gonna change. Actually, you're not gonna change anything that code up there.
Okay.
The change will be done here.
So I guess I gotta give a value to commission rate in here. But then if I do that, it's gonna affect the rest of the. If I ever try to run this again, it's still gonna affect anything else. Because if I give a constant value to this.
No, not gonna. You're gonna get this value here. You're gonna give this value, whatever's been sent in. You're gonna give that
Or
value
double
there.
commission rate and then equals to 200 and blah blah.
No, not that yet.
No.
Its bottom line is that this value needs to end up here as well.
This value needs to end up where? Here?
Where is the commission rate stored in the class? Where is it? No. Okay, show me where that is declared.
Oh no.
Yeah.
It's
Okay.
declared here.
Declared there. So that's where it's stored. So set to it.
So I have to set the value here, because then that means if I put commission rate.
No, not there. You see, this private field is accessible through the entire application. So anywhere in your code, you are already doing that here. You see, you are accessing it here. The private one, you are using it here. So you set to it.
So
Sorry.
No.
This one here is coming from here. That's fine. This one is coming from here. But the point is that this guy here, the value needs to end up inside of this guy.
So this value needs to end up here.
Yeah.
But I have to declare this value for it to be here, because.
Well, you are passing it. You are passing it from the sales transaction. You are already passing it. Go back there.
Oh, here.
Yeah, sales commission rate.
Yeah,
Where
I
is
put a value, but I have to put a value here for the sales amount as well.
that's fine. Sales commission, you're putting 200. Is that?
Yeah, sales. This is because first is name, 2
Okay.
sales amount, and 3 is commission.
Commission is
Commission rate.
usually it's a
And it
percentage.
gives you the commission. Okay, because then your question is to give me a commission of 200.
Yeah. So okay. So just make sure that commission rate is a percentage on top of the sales. Okay. So 200 doesn't make too much sense, because 200 is 200% of the
No,
value.
yeah, that wouldn't make sense.
That's
Because
fine.
In this case, the commission had to be 1%.
Okay. So first of all, send 1%.
I can set to 1% here.
Yeah.
for
So
example.
send it there.
So if I do this, and I put 1.
Perfect. Okay,
Here.
that's fine. So now that value there, this becomes 1, correct?
Yeah, that becomes
so
1.
how that 1 will end up here? You have to. I'm not going to give the answer. You have. So what was the question?
I don't know.
My
This
question
one is
was
different.
Use it this. Use it this keyword.
I use this keyword here, but somewhere I don't know. I can put here, for example, this, but it's still.
Look. Click here. How come you are using here? You are doing it right here. Look at this.
No, but this is the third one. The third.
That's fine.
constructor
But
action.
you are using it here already. You are setting a value here. How come you cannot set the same value here? I mean, use it
They
here.
asked us to do this.
No. I didn't ask to specifically do like this. I said that store the value. Again, break.
I guess it's pretty much answered my question.
Is that the same towards the same? Let's give this a try. Yeah, go ahead. Put it there. Commission. Okay, no problem. Have a good one.
Rate equals.
Now, use the lowercase commission rate.
Oh no, did I put uppercase or no?
It's uppercase right now. Now, commission rate equals to what? No, don't.
This, that. Nah, I don't know. I'm getting confused. I feel like I'm guessing right now because I need to understand what's.
Okay, so here, what is this? Where is this commission rate? What is it? This one here. Yeah, what is that?
This commission.
Yeah, where did you declare that?
It's. Where did I declare it?
Yeah, where's declared?
It's declared in here.
No, it's not
setting
declared
this
here.
value
Where
in
did
here.
you where did you say commission rate is a double? Where did you say that?
Oh no, I said that up already here.
Yeah,
Okay.
that's fine. So scroll down. How can you assign this variable to this one here? You assign them. This needs to be equal to this one. You just assign one to what? To the other.
So wait, so do you want him to assign this value here?
I want this variable to end up with this value here. That's what I want.
It's a return value then. Return.
Return.
No, I can't have this is a constructor. That's what I'm
No,
trying
we're just setting the values. Whatever is coming as parameters. Again, you are doing this here. That's fine. Here, that's fine. The thing that you are getting hooked up, you get confused, is that yes, here you are using properties, but here you are using private fields. That's fine. You can just say commission rate equals to. Put it there. Just type in. Let me. Equals to commission rate. Commission rate.
No, but that's what we.
Wait a second. Go ahead. Go, semicolon there. The end. Get rid of the second line.
This one.
The third line. Sorry, the fourth line.
This one, right?
Yeah. So that's kind of what needs to happen there. You need to. The commission rate that is declared up there needs to be set the value that is coming in. Now, the only problem here is that
It's
you
the
are
same name. That's the
yeah. So you solve that by doing what?
I can change the name.
No. Don't change the name because that's the easy way.
No, but that's I know that's a warning, but
No, that's a valid warning because this here what you're doing is you're saying commission rate this guy is equals to this guy.
yeah.
So that's what you're doing.
Oh, so he needs this.
Yes.
Honestly, I did this before, but it's still like I don't understand why.
Okay, because now
Because I know this
now
right
the
here
the
is from
confusion.
this one.
Yes.
Yeah.
So is it the
But-
same like this is the one?
This is what I've.
Okay, but here's the thing. Commission rate it's supposed to be read only. If you are being able to do this, it's because commission rate is not read only.
I did this earlier, but I wrote it like this earlier.
Yep.
But the reason why I took it off is because, okay, I know I'm saying this commission rate because I'm talking about this one here.
Yep.
When I say this,
Read
and then
only,
which
which is-
equals to this
okay,
one.
there you go.
Correct.
The thing is, we're not defining. We don't know. We're not defining this value here.
We are when we are calling the construction. Go to the other
Oh,
file. You're defined right here. One.
I mean, yeah. Now it's one. Okay.
Well, it will be one if you use that constructor.
Yeah.
Okay.
Thank you.
No problem.
Professor, so I think it might be the same question
Okay.
that you were just asked. I'm having trouble understanding this here. So demonstrate each one of the three constructors in the main method.
Yep.
So in the main method, in the main method I have sales 1
Yep.
with the 3 things, so that it will come back John $200 commission.
Yep.
Now, with these 2 constructors, we were told to set commission to 0.
Yeah, that's fine.
So how are you expecting it to come back John 200 for all 3 of them?
Well, not necessarily. I mean,
Okay.
So again, this was just an example.
Right.
The values that you're going to put here, it's
Yeah.
really up to you. To
Okay,
say
so
it's John, it's Paul. Again,
Right.
the values are it's really up to you. But as long as you demonstrate that you can use
Number 1.
number 1, 2, 3, all 3 constructors, and you see some output there.
Okay.
And the idea for the output is that you can use the toString to give you the output right away. It says salesperson name equals to John, commission is this amount.
Right.
Again, you could just, for each one, you can just say sales1.toString,
Right.
and it would give this phrase
To
that
string
you
the
can,
method.
yes,
Right, okay.
which would just output that to the console.
Right, exactly. Taking in whatever
Whatever's there.
amount
Whatever
I
you put there,
in.
yeah.
Okay, so this is just I understand.
Just an example.
Fantastic. Okay.
For number 23, it's always 0. Whatever amount I give
For
it to you,
yeah, because again, yeah, most likely. I mean, if we have can you scroll up here?
Yeah.
Okay, so
the constructor with 2 fields.
so sets. Now here's the thing. If you just use the constructor, that's fine, but you have the option to modify the commission rate afterwards. Well, commission rate is not modifiable, is it?
Read-only.
Because it's read-only. Yeah, that's fine. So you're right. You're right. It will be always 0 for the other
He
ones.
just doesn't have a good job. He's not getting
Yes.
any commission.
I guess so. Yeah, because the other 2 are set into 0 on both of them. Is it both of
Yeah,
them?
correct. Over here it's asked for sales amount to be 0 and commission rate 0.
Okay. So let's see here with one parameter.
Yeah.
And set all the other. Can you scroll up a little
Yeah, for
bit?
sure.
So the
Fields to 0.
to 0. Okay. Okay, and this one commission rate to 0.
So that's
Yeah.
this one here.
Yeah, so it will become 0 on
So
both
no
of them.
matter
Yeah.
what,
yeah.
for that third
Only the first
constructor-
one will have anything relevant in terms of commission.
Okay, fantastic.
Okay.
Just, Professor, based on the conversation that we had 2 minutes ago, I want to make sure that I make it clear. These properties do the same things until the properties is read-only. Then the performance is different. Because that one doesn't get the value.
Okay. So here's the thing. Can you ask again? I just want to internalize that a little bit better. This.
Get properties.
Yeah.
Do the same thing until the properties are
Not
read-only.
no.
Not to do the same thing. Get and change the same value that we want, the private one.
Correct, both of them, yeah. But just be mindful that maybe because we're using very basic gets and sets, there's no complication there. You're just reading from and writing to. However, remember that you can apply rules into those values. Let's say you don't want values to be, commission rate to be 0, or however rule you want to apply. You can test if value is less than 0, throw an exception. What I'm trying to say is that you can create business rules to be applied to the property.
I have more options.
Yes, more conditions. Where if you go straight to the fields, you bypass the entire thing. You bypass whatever rules you applied. Now, there might be a case like the one that we are working, which, how can I save the commission if it's read-only? Well, you have to go straight to the private fields.
When it's read-only, I can change it with this only.
Yes. Not only, but it's not only with this, okay? Forget the fact that it's this. Forget the fact that you have to use this. You have to reference the private fields. Now, if the private field has the same name as the parameter, you have to use this. But if they have different names, you don't have to use this.
So when the properties are only read-only, I can change the value of the field only inside the class.
Yes.
And if they are same name,
Yes.
use the this.
Yes. Yeah. I think that's a good way to put it. Okay. Yes. Oh, done? Awesome. You can explain. No, I'm joking. Okay, so how are you doing? I have not been checking Padlets, but nobody is writing Padlets. How are you doing? Anybody super stuck? Anyone super stuck? A bit stuck? Kind of stuck? No stuck at all? Okay, so again, the idea is that by the end of the week, I'll provide a solution. I'll provide a video with step-by-step on how to solve this, how to put together. Again, I made things a little bit more complicated there because I made some fields read-only, and then you had to use this, and then you have to use that, and then you have to use all kinds of different things. But that's the idea of the exercise, okay? So if you have not finished, and I think that some of you have not, that's fine. You have a few more days to give it a try. But by the end of the week, I'll provide a solution and a step-by-step on how to work this, put this together. Not only showing the solution, but why we're doing what we are doing, okay? Okay, great. Let's go for a 15 minutes. And once we get back, we're going to talk about files and keep moving forward, okay? 15 minutes, and we'll come back.